you guys leave the night of the exam. But I couldn't do it this time because I had a couple of students who were out. And that would be an advantage to them if I sent out the solutions, and then they would see how the tests would look, and that would be a little disadvantage to you guys, so I did not do it. I will send out the solutions though right tonight, so you'll see what the solutions look like. Okay, I'll usually send out the solutions to the quizzes and the exams. Guys, any quick questions? Now you have a quiz on Wednesday. Here we go again, one of those little short items. It's about 30 minutes, and I'll let you know more as we start class what to expect on that quiz. Only 10 points. What to expect. I think, if I'm not mistaken, next Wednesday. Oh man, time's going. I think that's exam 2. So that means here I go. I got to get another review out to you. So you start practicing with that review. I'll probably have to get that review out to you this Wednesday. You'll pick it up, and then next Wednesday is exam 2. Please, please, we're working hard. My 2 TAs are working hard. I'm working hard. Most of my students are working hard. So I'm expecting good results. And then I'm getting a lot of good feedback. Yusujin just told me about 2 of my former students, right, in Math 7, are doing well. So my students, I follow my students. All these professors, I know all these professors on campus. I can just go up to them and talk to them, just like, you know, how's that student doing? And if they're not doing well, you know, I've always said this, I will find you. And ask, what's wrong? You got a fail on your first calc test? Shame. No. Okay, so I will find you if you start messing up in Math 7, because I'm going to work hard to get you ready for it. Sujin and Mr. Park, they're working hard to get you ready for it. That math lab is open. My goodness, this is one campus that has that math lab open up to, I don't know whether they close at midnight or 11 o'clock. I don't know exactly what time it is.
10 p.m.
What time?
10 p.m.
It's 10 p.m.
That's when they kick you out.
That's when they say, please leave. Yeah. And I think they're even open on Saturdays, aren't they? Yeah, I think they're even open on Saturdays. You want to stop by on Saturdays. And they have some online. Do they still have the online for the math lab also?
Yeah, they do.
See? How can you go wrong? How can you go wrong? Now, some of the homework I saw or did not see much of from some students. I gave you this time because some students had not bought their books yet. So I felt for you. So if you showed me just some little item of some sort that you had done, I gave you your 2 points for homework. Not next time. So next Wednesday, I'm expecting to see some work. So don't just walk up to me as you did last time and show me the work, and you have nothing. Because I will give you that look like, what? You have nothing? Certainly guess you're doing something in the homework. Okay, guys? So please, 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 I want everyone, I want every student in this class to pass with a C or better, hopefully B or better, and be prepared for calculus. So here's some good things about you when you leave. Because professors are always asking me, Frank, did you have a student? This student says he had you, or she had you. Yeah, how are they doing? Well, and if they say something bad about you, that they're not doing very well, I say, I don't think that was my student. I think you got mixed up somehow. They're my students, if they're doing bad. If they're doing well, oh, it's my student. It was mine. So guys, I want you to get you prepared. That's what it comes down to. Now here's where I am. I've got to do a little recap. On a Monday, Wednesday class, that's the difficulty. I don't see you Thursday. I don't see you Friday. I don't see you the weekend. And I don't know how much math two you're thinking of on those days. I think very little at times. But you got a life. You got other things to do also. I've got a life. We've got other things to do. So by the time we get back to Monday, you say, whoops, I've forgotten everything I saw last week. So I usually do a recap to move back into it. And also, guys, I'm hoping everyone has a copy of it. All right, just a second. I passed this out last week. Has some piecewise functions on it. And also it says section 1.2 1.4, and 1.6, I guess. Looks like this. I think anyone received it. Okay? So we'll follow this, but let's do a little recap first before I jump into where we should be. And then I'll have to let you know also about this quiz on Wednesday. Guys, overall, I'm proud of you. I'm very, very proud of you on that first exam. Okay, here's what it is. Part one, you might like a little recap here, is this. Do we know how to do this? The average rate of change. We discussed this in the 4 o'clock session. This is going to be on the quiz on Wednesday. Now, the quiz is short, but you have to find the average rate of change. Now, can anyone tell me, now I know my 4 o'clock people can tell me, but can anyone tell me what do we associate with average rate of change in order to find what they want when they say find the average rate of change? Can anyone tell me what it was associated with?
Slope.
Slope. I'll put on the side here. M for slope, change in y or change in x. And if you'll use this formula for change in y, and then compare that for change in x, no problem. And that's what it comes down to. Let's move on to slope. Now, out of curiosity, before I jump into an example here, does anyone, or can anyone tell me from the textbook, what did they describe as average rate of change from the textbook? Did anyone look in the textbook and see how they described average rate of change? I described mine like this. It was just slope. Does anyone recall how the textbook had this written? Anyone at all? They had it written a little differently. Yes?
Was it from A to B of f of x?
Yes. Yes, and how they have, right? F of B minus F of A. They wrote it as F of B minus F of A over B minus A. What they're doing is slope. Y1 subtract Y2, they replace that with F of B minus F of A going from A to B. And the bottom was B minus A. Same thing, guys, the slope here. Now, that said, though, before I jump into an example, also, we did this in the past. I need the equation of the secant line. The line that connects 2 points on that graph, or that function. Now, can anyone remind me, now again, my 4 o'clock session certainly could remind me, how to find the equation of a secant line? What does that come down to you as a student doing? Yes, sir?
Is it point slope form?
I prefer a point slope form, but it's in blue right here. So if you want to write the equation of the line, it looks like this. And it's called point slope form. Some students will like to use this, it's up to you. X plus B, slope y-intercept form. And that one's the point slope form. I prefer point slope form myself. So guys, average rate of change, we on the quiz. Write the equation of the secant line, and you'll say, Professor, can you give me an example? What are you talking about here? I'm going to name a function for you. Here's an example. And I have f of x is equal to, and I brought this one in. Try to find where it is. Yes. Oh, here it is. There's your function. Now I'd like to find the average rate of change on this function from x is equal to, let's try the -4 here, out to x is equal to 6. Now, if I provide a sketch, we're not at the point now where all my students can sketch this. If I should provide a sketch, guys, which if you need a sketch, I'll provide it for you. Some students in class will probably recognize that this is going to be a parabola. We'll be opening down. I'm looking at mine carefully. It looks like it's going to go through the origin, and I'm looking at it more and more carefully, maybe a square root 2, something like that. Guys, I'm going to say it looks something like this. This is just a rough sketch. Okay. Let's say it looks like that. I'll provide the sketch if you need it. And I want to go from -4 to 6. Well, you say, Professor, -4, the point associated is over here somewhere. And 6 is on the other side. Over here, let's say somewhere. How do we do this? It's right here. And those are my 2 points. Goes from -4 over here on the left over to a 6 on the right. Now, if you travel from left to right on these graphs, which you should do, I know and you know. Definitely, if you travel from the point on the left to get to the point on the right, you're doing some changes here. First, you're increasing. This piece of the graph is increasing, this function is increasing, then it hits a local max, and then it starts falling. From there until you reach your destination, which is right there. And what they would like us to find is, what is the average rate of change as you go from one point to the other, taking into consideration those changes, an increase and a decrease. So what on the average have you done here? Guys, some pieces are missing here though. They gave me x is -4. They did not tell me what the y was, which I'll need. They gave me 6, but they did not tell me what the y was. So what I must do, and we must do together here, is, on this one, to find what the y is, go back to my function here and find f of a -4. And replace, just be careful, and have this. This is where you might mess up if you're not careful. I'm replacing x by a -4 in my function. If my math is correct here, that's a -16. Subtract 2 times +16 when you square that. And you guys watch carefully. -16 subtract 32, yes or no? Is it -48? Someone check me. I did quickly. Is it -48? Okay, I see a hand going up. Say, Professor, it is. So the guys just call this -48. Close that out. Now the point's complete. The 6 on the other side, same thing. I need to find f of 6, which means I need to go back to my function, do a replacement. Just be careful. And it looks like I'm going to end up with 24. Do not let me make a mistake here. Subtract 2 times 36. And that's 24. Subtract 72. And guys, how much is that? 24 subtract 72, if all that's correct, negative something. Someone help me out. 48?
Yes.
Wow, okay, -48. So that means this point here is now complete. It is -48 for the y coordinate. Everyone with me now? Now, what does it come down to us doing? Well, we've got to now, I'm doing in green, visualize this being connected by a straight line. I don't have a straight edge to use here. Say the line looks something like this. That's called the secant line. And find its slope. It all comes down to slope. So guys, on the side here, the slope, I'll put it in green. Delta y, changing y for changing x. And you say, Professor, how should I label my points? It's up to you. I'm going to call myself, this one the x1, y1 point. And this one is the x2, y2 point. Entirely up to you though. You can interchange them. Changing y, y1 subtract y2 in my slope formula will be a -48. Subtract, looks like a -48. Did I get -48 on both of them? Nice. That's what I wanted. And changing x, x1 minus x2, the way mine's labeled, a -4 subtract 6 looks like. x1 subtract x2. Guys, something interesting is happening. Do I get a 0 here? Over a negative 10, which is 0. Yes or no? Which can happen. The slope is 0. Now, before I finish up, write the equation of the secant. That's called the average rate of change. On the average, this is the way this function behaves. The increasing decreases cancels out each other. It may be increasing, maybe decreasing, but in total, they cancel each other out. And I've got average rate of change of unusual 0. Yours more than likely will have a number on Wednesday. Now, if that's true, can someone tell me, before I write the equation of the secant line, in other words, I want to use this up here if I could, in the blue. I'm going to jot down that I need some input from someone. Point slope form. Anyone tell me, I'm going to put my numbers in, what unusual happened here, which can happen, if this one came out to be a slope of 0. In other words, the average rate of change is 0. Can anyone tell me what might that mean? Thank you. When you say a flat line, give me another word. I like that. Flat line, something else. Is it, when I connect these two, I did this on purpose. When I connect these two, did they actually line up perfectly? Did this one drop down to a negative 48?
Yes.
Did the other side also drop down the same distance? So actually, if I connect these two, I made this happen for the purpose of what I'm doing here. If I connect these two, that green line should be I heard flat line or a what? Horizontal line. Shouldn't it? Just a straight horizontal line. Please tell me from algebra, what's the slope of any horizontal line in algebra? 0. That's why we give it 0. This would be actually a horizontal line here in the green. I still need its equation though. So if I am patient, put in my numbers here, this is y subtract y1 is negative 48. Slope, interesting, 0. And then x subtract a negative 4, the way mine's labeled. And step back to look at it, see if you guys agree. It looks okay to me. This becomes y plus 48. Interesting. That side's 0. 0 times anything is 0. Move the 48 over. Are you kidding? Now I said, Professor, I thought it should have looked more like, when you finish up, maybe like this. Can I easily make it look like this? I just got y is equal to a negative 48. If you did this on the quiz, if this were the problem on the quiz, you receive 100%. It's correct. If you say, Professor, can I write like this? And make it look more like this? Write a 0x minus 48, same thing. Okay, so guys, just understand the concept here. To find the average rate of change, it comes down to finding the slope, and you have to write the equation of the secant line. Wow, that's one question on the test. The other, part 2. Now I'm going into the handout. Sketch. And I'll have only one of these on the quiz. We're going to sketch a piecewise function. Now, this was on the handout. We did this in the 4 o'clock session. You guys who were with me at 4 o'clock, I'm going to redo for the entire class now. That same problem number 1 there. Would you read that to me? It's in 3 pieces.
Base f of x is equal to 2x plus 5 if
2x plus 5.
negative 3 is less than or equal to x
Less than or equal to x.
less than 0.
Now hold on, I'll do that in black. I'm going to use different colors here. Now, by the way, before I ask her to tell me the other pieces to this function, piecewise function, what would that first piece look like? It's a piece of a what? It's based on your knowledge of just observation here. What should this be a piece of? A piece of a parabola? A piece of a circle? A piece of what? A line. It's in the m x plus b form. and we'll get a piece of a straight line. Now the next piece, I'll put in blue here, what was that?
-3 if x is equal to 0.
Now, that's unusual, but we'll see what that is. Okay, it's the grid. And the third one, I'm gonna try the green, the green will hold up for me. I'll try the red. What's the next one?
X squared plus 1 if x is greater than 0.
Okay. We'll go right. Piece by piece. Now, how many pieces have I seen on some of these piecewise functions? Many. This one has only 3. And usually for a math 2 class, I stick with the max to be a 3. I've seen 4 pieces, 5 pieces, 6 pieces. We'll stick with, for a max 3. I got a max of 3 here. Guys, we'll sketch this as best we can here. And if I can make it work out for us. Now, some students have had some practice, I'm sure, with piecewise functions, which is beautiful. But I would suggest this, just to play it safe. The black, the blue, and the red, I'm going to try with the help of a table. So on the side here, translated, they're giving me that I'm allowed to try for the x. Replace the x with anything from -3 up to 0, including the -3. Not including the 0. You may say, Professor, what does it mean? Well, visually, it means this. You're going to have a table. You get to start at -3, and with a little space, you got to stop at 0. Now, anything in between is also allowed. Now, a student asked me earlier, how many points should I plot in between, Professor? There's an infinite number of possibilities. Usually, I just plot one more to see what's going on. So something called between -3 and 0, guys, I'm going to try maybe -1. And let that be a demonstration. Now, I'm trying x equals -3, I'm going to replace x by -3 right here. So if I go back to my 2x plus 5, replace x by -3, can someone help me out? 2 times the -3 plus 5 will give me a what? -1. I'll plot that point here shortly. -1, take -1 back, replace it in the black. So 2 times the -1 plus 5 gives me 3. We'll try that. And finally, I have 0 here. And I'm patient, put a 0 in here, guys. 2 times 0, 0 plus 5 gives me a what? 5. That should be enough. I'm going to go to the grid and get that done now. That'll be enough to see what the black piece looks like. First one's -3 down 1. Let me get ready for this. You guys, -3 down 1. I'm going to label one like this. I'm right here. Now, -3 down 1 when I plot the point. I notice they have an equals mark here at -3, which says I may include this point. In other words, darken it in when I plot it. So -3 down 1, darkened in, right there. My point that I chose, definitely is going to be included. -1 up 3. Okay, -1 up 3. This is a rough sketch we're doing. And it's going to be right here. -1 up 3. 0, 5. I'm on the edge now. I noticed when it gave me 0, there was no equals mark here. I'm going to plot it, but 0 up 5, when I do plot it, must be open. Cannot include it. Now, they're supposed to line up. So I'm going to make mine line up. So here, guys, should be a piece of a straight line. That looks better like this. There's the piece of the straight line connecting those points to represent the black piece. A piece of a straight line. Are we okay so far? I would use those tables. The one in blue is a giveaway. No table needed. If you look at it closely, it merely says this. When x is 0, in the blue, y is -3. That's all, no table. So just plot that point, 0 down 3. And said, Professor, no problem here. Up down to a -3. And we have this. And it's darkened in. That's the equals mark up there. And guess what? That's piece number 2 done. There's no line here, just a point. Next one is a piece of a parabola, but I'm going to use a table. And in that table, they say start out with 0, which I will. And then I'm allowed to try anything greater than 0. I'm going to try a couple of numbers, guys, like a 1 and a 2. It's up to you as to what you select for numbers. 0 placed in the red, 0 squared plus 1 gives me a 1. And I will use that shortly. Put a 1 in, 1 squared plus 1 gives me a 2. I'll use that. 2 squared plus 1 gives me a 5. Now, before I plot those in the red, you can actually get a piece of a parabola. Based on the given, what they gave me, am I allowed to, when I first plot 0 up 1, am I allowed to use it? In other words, am I allowed to darken it in? No, there's no equals mark there. You got to pay attention to that. So 0 up 1 will be open. The others, definitely my select numbers will be included. Out 1 up 2, and out 2 up 5, no problem. If I get this down here, out 1 up 2, guys, is right here. Out 2 up 5 in here, and you can plot more points if you wish. Connect those, and we're going to have a piece of a parabola, something like that. It's got a curve to it. Do you guys agree? Does it look something like that? Now, for some of my students, I don't know, you may have seen a piecewise function 10 years ago, when you first or last had a math course. Some students may have had it just recently. Are we okay on that? Now, the domain of this graph. The domain on the entire graph, from left to right, on the x-axis. Guys, can anyone describe for me from left to right? What would I use to show the extent from left to right of this graph? I see a hand going up. Yes?
From -3 included.
-3. Now, is -3 to be included?
Yes.
Bracket. Okay, and how far out does it go?
To 0 not included.
See something better than that.
Infinity.
Does it go all the way out to infinity? Does this rise? I see it's rising forever. Now, he said, as it's rising forever, it is also going out this way forever. So it's a -3 through infinity with a parenthesis. You never put a bracket on infinity. So it starts here on the left, and it goes forever on the right. Range. The range is a set of y values. That's the up and down. That's unusual. How far down does my graph drop?
-3.
-3. It's all by itself down there. No interval notation. It's going to look a little unusual, but we'll start out with -3 all by itself. And then it picks up with, I think it picks up here, and then goes up forever. And how would picking up here going forever look? Let's put union. And guys, union what? Was that -1? So it's -1 for the y, and look at the y's here, and should that be included? Looks like it was, darken in, -1 bracket. And does it rise forever? Through infinity. There's your range. What a way to say happy Monday with a nice piecewise function. Making sense? For the range, the up and down? Yes, sir.
Why don't you put -3 in brackets?
Ah, beautiful. Look at this. Would I count it wrong if a student did this? I would not count it wrong. We usually reserve those brackets for intervals. And this is not an interval, it's just a single number down there. But if you did, we're okay, no more kind of problem. Guys, anything else there? I'm not quite finished with the problem here. Here's the crucial part. Can you graph this? Can you take those 3 or 4 pieces and put them together and graph it piece by piece, where some pieces are on the edges open, some are closed? So you've got to be very careful. Before I leave this one, guys, I will have a question something like this. Find the value of, based on this piecewise function, this. Why not? Yeah. Okay, or something like that. Now, I want you to find a function, value for me. Now, don't be misled. I've had functions in here in class before. It says f of a -2. That does not mean you go here and replace x by -2 and x by -2. Down here, you cannot get 2 answers. What it means is you got to select which of these 3 pieces does your x fit. You guys got f of a -2. Where does -2 fit? Does it fit the black one? Is -2 caught between -3 and 0? So I'm going to use the black one to get the answer for, right here, f of -2. You can do it. Go to the black. 2 times a -2 plus 5. -4 plus 5. Let's check my math out here. Is that a 1? Yes or no?
Yes.
And then on the outside, you finish it up, it says -3 times that, and I'll come back to it. Second term, 2 times f of 0. Well, the blue one, that's where 0 is. Is that true, guys? And we'll go to the blue and have 2 times, and it looks like it's -3. And I'll come back to it. Last one says subtract f of square root 3. Now the square root 3 fall here, here, or in the red one. Where do you think square root 3 falls? Because that tells me which piece to use.
Yeah, right.
Is it red? Why?
It's bigger than.
Is square root 3 going to be a positive answer, a positive number? And does this right here say anything greater than 0? So square root 3, I don't know the exact value for square root 3, but does it fit here? X is greater than 0. So we use the red one and find it to be merely square root 3 squared plus 1. And then do the calculation. So this is -3. This, I think, is a -6. Down here, guys, I think, help me out here, is that 4? In fact, it's -4. 3 plus 1? All together, -3 plus a -6, if there's no mistake, subtract 4, is that a -13?
Yes.
I did it quickly. So all this is equal to this. A -13. Now, before I move on to the next one, is there any concern here? So you have to be very careful which piece you go to. You can't go to 2 pieces. It will be a function then. Yes?
I just had a question with the equation next to the find. Where'd you get the numbers from? And what?
Oh, I placed it out just at random. These not numbers here?
Yeah, the ones.
Really, I just created this one.
Okay,
I just
so
created.
that's not like a set equation.
No. It's in the blues. I just created that problem. Okay? Anything else? Now, quiz number 2. You're going to have this and one of these. I'm not quite finished with this. This one's finished. We've got the domain, the range, and then some function values. We'll call this part A. Can someone remind me on your handout, was there another piecewise function?
Yep.
I need to sketch it. How many piecewise examples did I have? 2 or 3? 2. Can someone please read to me number 2 to graph?
G of X.
Okay, G of X.
Equals, bracket, 4x plus 8
4x plus 8.
if x is less than -2.
Okay, written like that. I'll do that one in black. How many pieces are there? 2?
3.
Oh, 3. I'll go with the next one.
X squared minus 4
Uh-oh. X squared subtract 4. If
-2 is less than or equal to x less than 2.
less than 2.
Yes.
Beautiful. And the last one, I'll try that in, I guess, the blue.
Square root of x minus 2
Ah, cute.
if x is greater than 2.
Beautiful. And they want those 3 pieces sketched. Let's do tables. I think tables are a big, big benefit here. Guys, the black one, show a table, an illustration. Oh, wait, can anyone tell me if I see 4x plus 8? Should that be a piece of a what? A line. It's in the mx plus b form. So it should be a piece of a line. What piece is it? Well, let's determine. We'll start out with -2. They gave that to me. And they're telling me I can try anything less than -2. Like -3, -4. You can try as many as you wish. Now, since I know this is going to be a straight line, 2 points determine the line. So would 2 points be enough here? Even though you can try more.
Yes.
Should that be enough? I'm going to try 2 points then. I'm going to replace x by -2 in the black. 4 times a -2, -8 plus 8. That's interesting. 0. Put a -3 into the black. 4 times a -3 is a -12. Plus 8, please tell me, is that -4?
Yes.
And, if you don't mind, you get all my tables out of the way on this one, then we'll put all this together on a grid. Now let's go to the red one. The red one looks like it's going to be a piece of a parabola. And Billy gave me, I'm allowed to try -2 up to 2. Notice I left some space there. -2 up to 2. Quite a few numbers caught between. You get to try something in between. You may try just one number, it may be enough. Guys, we'll try 0. If that's not enough to get good shape, I'll go back and try something else. Besides 0, add to it. Okay, -2. Let's try -2 first. If I put a -2, -2 squared is 4. 4 subtract 4 gives me a 0. 0, which falls in between. 0 squared is 0. Subtract 4 gives me a -4. Do not make a mistake here. Put a 2 in. 2 squared is 4. 4 subtract 4 is 0. Yes or no? Now, I don't have this plot yet. Blue one. Well, the blue one's interesting. It's a square root. Let's form a table best we can. Now, I know what a parent graph for a square root looks like, and you do. Let's start with 2. They give that to me. The blue. Put a 2 in. 2 subtract 2 is 0. Square root of 0 is 0. And I'm allowed to try anything greater than 2. Now, would you like to try numbers that maybe will be doable? Or act nicely for me? Let's try a 3. Which I'm allowed to try. Anything greater than 2. If I put a 3 in, guys, 3 subtract 2 is 1. Square root 1 is nice. It's 1. Let me throw in another one that's nice. In fact, you guys probably can give me another number here. What else, if I replace x by it, would give me a nice answer? 6. We'll try 6. And 6 subtract 2, of course, is 4. Square root 4 is a 2. And there's the blue one. Now, what on earth is this going to look like all together on a grid? See what it does look like here. Just a rough sketch. Let's get the black one out of the way first. -2, 0. Start it out here. And by the way, guys, when I plot negative 2, 0, am I allowed to use it or not? No, I don't see an equals mark there in the original. Open. My other point, negative 3 down 4. This is out here. And if I show negative 4 on this rough sketch. And that definitely can be included. So it falls right there. I got negative 2, 0 open, negative 3, negative 4 can be included. And then connect those, and please tell me the way it looks, is this the piece of the straight line we're looking for? I'll move that over to make it work. Guys agree? The red one should be a piece of a parabola. Now I have in my table negative 2, 0. This is interesting. I have a negative 2, 0 for the black. Now I've got negative 2, 0 in the red. What can I do for the red one at negative 2, 0? Am I allowed to include it? I see the equals mark there. That means, interesting, I get to close this in. For the red one. We're trying to the table 0 down 4. Okay, that's definitely down here. And 2, 0 on the other side would be here. And that also can be included. Now guys, please tell me, are those red ones plotted correctly?
Yes.
Woo! Now, was I supposed to include the last one? Someone tell me. I'm out here at 2, 0. Was that point supposed to be included on the red based on the way it's given to me?
No.
No, there's no equals mark there. Open this up. Connect those. It looks like I'm going to shape something like a parabola. And see if you guys agree. Does it look something like that? Wow. Third piece. I guess if I give you one of these right here, it may take all 30 minutes on one of these. The blue one, I've got 2, 0. Oh, there comes that 2, 0 again. If it's here on the black, it's on the red. No, this is 2, 0. It's not negative 2, thank goodness. Okay, 2, 0. Am I supposed to include 2, 0? No, it's supposed to be open. Is it open already?
Yeah.
Beautiful. Out 3, up 1. Definitely out 3, up 1, I will include. Put it right here. In fact, I should put it in blue. Right there. And I threw in another one, you guys help me out, what, 6, 2? Which goes out to 6. I have to extend this. 5, 6. And we're supposed to go up to, like a 2 here. There's something like this. And see if you guys agree. Is that true? Now keep in mind now, also this. Came up again. Are we okay? Connect. Should I connect with a straight line? No, you know the shape of a paragraph or a square root. Has a little curve to it. This is something like that. And it continues. Do we accept that? All 3 pieces have now been put together on this graph, some open, some closed. Now let's list the domain to range if we can on this entire graph. Domain, guys, from left to right, looks like this indicates to the left. Is it dropping down? I know it's dropping down, but is it moving out to the left forever? So negative infinity. How far out does it go? It looks like it's positive infinity. Yes or no?
No.
Uh-oh, what happened?
2 is open.
Okay, 2 is open. Okay, now you said, Professor, hold on. Yeah, negative infinity over 2, that's open not included. So you think 0. Then what?
No, not 0.
I mean, 2 here, and then from there, what?
2 to infinity.
Yeah, 2 to infinity, that's what I was looking for. There. That's true, guys? Had to break it up, negative infinity over to 2, has y value 0. And negative infinity over to 2, then 2 through infinity. Domain, range. Geez, the up and down. What do you think the up and down is? I say it's dropping down forever. That's negative infinity for sure. Now, can I say, since it's rising also forever, can I say positive infinity? Now, what point might you be concerned about? This point right here at what, 2, 0 was it? Is that true? So wait, Professor, should you do something like you did on this one? Can you express the domain, the extent of the x's from left to right? You wrote like this. Now you're saying for the extent of the y's, the up and down, it's negative infinity through positive infinity. Those are the y values. And you're saying, wait now, this one has a y value of 0, and it's not included. Is that y value of 0 being picked up there? If you actually label this one, which is part of the graph, is this one labeled as negative 2, 0? Is that 0 included? And that's why I can say yes. That 0 is being picked up. You understand the logic there? Okay. Now, was that the last one, Billy? Was that the last one I had to graph?
Yes.
Beautiful. Guys, can you do one of these for me? Now, you guys are bringing in colored pencils, or do what you gotta do. It might help do these pieces in different colors. I would certainly suggest you do this. By the way, do the tables help to illustrate what it means, what's allowed to be used on the side there. I think the tables help. Okay. So a piecewise function of some sort you quiz Wednesday, and an average rate of change. There's a secant line. Only 2 problems, by 5 points each. Okay, any concerns here? Before I leave it? Now what I gotta do, that's part 2. Part 3, I got them way down here on the end, so make sure you see this. I brought in some items myself, and that is, hang on, beautiful. Let me ask you on your handout. Did I have a section number like 1.5, is it coming up?
Yep.
And what was the label there for 1.5? Transformations. Oh. Let's say as a student, you're now maybe getting comfortable with what a square root graph looks like, what a parabola looks like, Professor. I'm sure you're getting comfortable with what it looks like. And now you're asking me to maybe do this, and we're going to do it here. This. Now take one of those nice graphs and transform it. And I think I have written on that handout some transformation strategies. What they're going to ask you to do it, they're going to ask you to take the graph and shift it to a different position. They may ask you to shift it up, shift it down, to the left, to the right. They may ask you to stretch it. They may ask you to flip it over upside down. Now, can someone read to me the few that I gave you on the handout that might help me to do what I got to do for transformations? Who would like to read for me? Someone. Anyone. Billy.
And some other vertical shifts of graphs.
Hang on now. So the first one I mentioned was vertical shift. And what does it say in your handout?
So it's to graph y equals f of x plus c. Shift the graph of y equals f of x upwards c units.
Okay, so you're saying if I see this, y is equal to f of x, I think you said plus c?
Yeah.
that means to vertically shift the graph up C units. Is that true? Well, let's look at that shortly here. Go to the next one.
To graph y equals f of x minus c, shift the graph of y equals f of x downward c.
Oh, hang on now. So, okay, got you. You're saying, hold on. Vertical shift from this right here then. If it looks like this, put these together. If there's a minus on the end there, Billy, you're saying shift it down.
Yep.
Okay, now read another one to me.
So there's horizontal shifts of graphs.
Okay, horizontal shift. All right, tell me what that says.
To graph y equals f of x plus c.
Oh, hold on. F of x plus c looks like this. And what does that mean to do if I see it?
Shift the graph of y equals f of x to the left c.
Oh, I gotta move to the left horizontally. Okay, horizontal to the left. Use the green marker here. And did I throw in another one there?
Yeah.
Like what?
To graph y equals f of x minus c, shift the graph of y equals f of x to the right c units.
Okay, if it looks like this, so horizontally shift it to the right. Okay, horizontal to the left, horizontal to the right, and that takes care of my horizontal shift. What else did I list on there for transformations?
Reflecting graph.
Okay, hang on now, number 3. Reflecting, was it?
Yeah.
Okay, reflecting. And tell me the way it's written there in the handout, and we'll take a look at some examples here shortly.
To graph y equals negative f of x, reflect the graph of y equals f of x on the x-axis.
Okay, now if it looks like that, you gotta reflect the graph through, I think you said x-axis?
Yeah.
Got you. And let's include the next one. What was the next one?
To graph y equals f of negative x, reflect the graph of y equals f of x on the y-axis.
It looks like that. Reflect through, I'll save myself a little time here, y-axis. Now, Billy, tell the class, did I have more listed than just this?
Yeah.
Okay, we're gonna stop there for right now and take a look at what on earth does this mean? Professor, what does the transformation? You're gonna give me a graph and ask me to transform it, and I'm getting a little scared. How scared should I get? Well, let's see what happens here. This may take me up to the break here. Okay, guys, we'll jump right into it. And we're going to try this. Sketch this. Y is equal to negative x plus 2 squared, subtract 4. And I'm going to sketch it using transformations. That's the way it looks. Now, I think the one I just created takes into consideration these 3 that she's given me so far. Now, I will ask you when you have one of these, maybe on the exam next Wednesday, to name the transformations. Guys, the negative sign stuck out front. I'm doing the red. Looks like which of these 3 that I have listed might apply here? Is it this one right here? Is there a negative sign stuck out front?
By the time,
Yeah, right here. And if I look at that right there, negative, what does that mean the graph may do? It may reflect through which axis? The x-axis. So we'll write this out. This is a reflection through the x-axis. I will ask you to write those words out for me. Now go further, I see an x plus 2. Billy, gotta be careful. X plus 2 looks like inside here, it looks like that. I think this is the transformation strategy that applies. Is that true? X plus 2. What should happen? There should be a horizontal shift to the left. How many units?
2 units.
2 units. So it's a horizontal shift to the left, guys. Let me try it in this color here. We'll work over the brown. Okay, horizontal shift. To the left. 2 units. And then she gave me a subtract 4. And Billy looks like subtract 4 on the end may be more like this one. Is that true, guys? Now tell me the description. What should I be doing there in this case? A vertical shift down 4. So write this out. Try green here. A vertical shift down. And those are my 3 transformations. To do. To do on what? On a graph. Where's my graph? Does me go back here and do those on this graph here? No. So you do transformations on a graph. I need a graph first, and I'll start shifting and doing what I gotta do on that graph. What's the graph here? Well, it looks like this gives me a hint right here. It's being squared. Is that a parabola?
Yeah.
So I need a parent graph for a parabola. Guys, please, did I give you guys a handout of the parent graphs?
Yeah.
So I need first, to do all this together before we take a break here, I need first to show the parent. And then we'll be very patient here. Here we go, guys. I would say the parent graph looks something like this. Should I be labeled? This is a basic x squared graph. Should place arrows on the end there because it goes forever. The red says take that graph from left to right, take that black graph and reflect it through the x-axis. That's what the red says to do. I would think not much of a problem here. Might it look something like that? If I reflect the graph through the x-axis. Not drawn to scale, just trying to follow what Billy read to me. Should be a little bit skinnier than mine was. I made mine talking there look like that. That's okay. Maybe something more like that. Labeled, y is equal to for the red. The red's representing this. Now from left to right, now into this color. It's supposed to be brown. Horizontal shift to the left, 2 spaces. So pick up the red, now shift it to the left 2 spaces. If I do, please tell me, just a rough sketch, is the graph now over here? Doing something like that? Yes or no? And at this point, is it labeled as y equal to negative x plus 2 squared for representation? Finally, what am I supposed to do now in the green to get the final result? Vertically shift down that brown or black graph there. Shift it down how many spaces? 4. I shift down 4. And I know this point right here now will be down here. At -2 down 4. And please tell me, are we saying the graph may look something like this? For the final graph? Yes or no?
Yes.
There's the graph of this. That's the final. That's what they want. That's the graph of the function. And we did it in transformations. Do we agree, guys? Saw a hand going up. Yes?
On a test, would you want us to show each of the stages of the
You have to.
model? Okay.
You have to. So you see this on the exam next Wednesday. You'll have to show me the parent graph and then hopefully in different colors or some way, each transformation. Yes?
What is it the black one?
Brown, black, yeah.
Brown one,
Right here,
-2, yeah.
we're shifted over to the left. 2.
Oh, got it.
I got in the brown there, right? Is that true, guys? Now, if that's the result, I'm saying that, green graph down there, that's it, that's what they wanted. Now, let's list the domain and the range on that green graph. Guys, the domain on the green, from left to right, the way it looks might be negative infinity to positive infinity. What might be the range, the up and down, described as for that green graph? Looks like negative infinity for sure, it's dropping down. Up to, I think -4, was it? Including -4. And there's my domain range. Interesting, isn't it? I've got more transformations to show you. Now, I know it's almost time for a break here. I need to talk to you about something also before you leave for break. Before I do this though, let me real quickly point this out. This is finished. Now, if, Billy, you gave those transformations, I know I had more to do after the break. If this had looked like this, and I'm gonna do it now. What difference does that make? Not, hang on. Let me look at, nothing about the shifts. How about a different parent graph? The parent graph's not the parabola this time. If I should do this one, what is it? It's the square root graph. Isn't it? You have to start out with the square root graph. And then go through those transformations. So it all depends on you identifying what should my parent graph be. Should it be a parabola? Should it be a square root graph? Could it be an absolute value graph, Professor? It depends on that parent graph. Before you leave, I need, in this clever class, someone to tell me something about this. I'm going to do it real quickly here. Hang on. I don't want to make a mistake. Okay. I'm going to take a break here shortly. Oh, that's cute. Now, can someone in this clever class tell me before we take a break, what's the relationship between, I see quite a few relationships, between the blue that we finished up and this? You did it right. Here's the blue was given to me. What relationship do these two have?
Same function.
They're the same function. They're the same function. If they're the same function, should this, if you see on the exam next Wednesday, which you will, it not given to you like this, like Billy gave me my transformations here. No, it's given to you like this. And the graph is also this. This in the green, I think, was this the resulting graph on the one I just did? This is the graph of this. They're the same. Can anyone, before I take a break, tell me something from last week, something from your exam, that you would have to do, and we may have to do it tonight, after the break, to show for sure, Professor, if I see this first, I can change it to this. You'll have to complete the square. You'll have to take this and complete the square process and change this and make it look like this, and then you easily graph it from here. Make sense? So if it's given to you like this to begin with, and I know it's equivalent to this, you'll have to complete the square. And that might be a different conversation altogether after the break. Okay, guys, now some students have not picked up their exams yet. I'll get those exams to you guys. So go ahead and take your, what's it, 10-minute break? Okay, go ahead and take your 10 minutes. Now, if you have not picked up your test, come on up. I'll get the test to you. Take a break.